I'm going to describe 74LS163 IC and also their pin configuration. And also I'm going to provide clock pulse or clock signal from ADLM1000 to our second pin of IC 74LS163, which is also known as clock pin. But here is a little problem, that our Atom is CMOS based and our IC are TTL based. TTL require base current, but CMOS don't require base current. And ADLM can't supply that much, so it produces error. So to avoid it, we use IC Cd401063 and also we can use 555 timer IC. In this video, I'm going to do two experiments. In first, I'm going to use IC74LS163 and Cd401063. And in second experiment, I'm going to use IC74LS163 with 555 timer IC. Circuit diagram of IC74LS163. The IC74LS163 is a synchronous counter, as all 4 flip-flops are integrated into the same chip and they receive the same clock pulse or clock signal. The IC74LS163 is a completely programmable binary counter due to its 4 present inputs, which allow it to begin counting with any loaded input by sending a low signal into the load pin. The IC74LS163 contains 16 pins. Now I am going to describe all pins one by one. The first pin is a clear pin, which is also known as master reset input, and it's used to reset the whole IC. The second pin is a clock. It is also known as clock pulse clock signal. It is continuous high-low signal which will use to trigger IC. That's why it is also known as trigger pulse. A, B, C, and D are present inputs, in which A is the least significant bit LSB and D is the most significant bit MSB. The 7 pin and 8 pin are ENP and ENT. They both are two enable inputs of the IC74LS163. Both ENP means enable parallel and ENT means enable triggers should be set to high value in order to increase the count. The 8 pin is a ground pin. The 9 pin is a load. This is active low input, logic 0, used to load the data to flip-flop output. If this terminal is supplied with the logic high, then the loaded present input will not be shown in the output. QA, QB, QC and QD are the QC and QD are the output terminals, in which QA is the least significant bit LSB and QD is the most significant bit MSB. RCO, which means ripple carry output terminal, goes from logic 0 to logic 1. Once the IC reaches its maximum count, that is 1111 in binary, and in decimal it is 15. This signal is used to cascading of IC74LS163. Here is circuit diagram of Cd401063, which we are going to use with IC74LS163. Cd401063 IC contains 14 pin. Out of 14, we are going to use only 4 pin. First pin, second pin, 7 pin and 14 pin. 7 pin is a ground pin which is connected to negative voltage. 14 pin is a positive pin which is connected to 5 volt input voltage, which we are providing through ADLM1000. The first pin is a channel A input pin. The second pin is a channel A inverted output. In the first pin, we are going to provide clock pulse or clock signal from ADLM1000 to IC-CD401006. IC-CD401006 modifies that clock signal and give it back through the second pin of the IC-CD401006. And that modified signal now goes into the second pin of IC74LS163, which is a clock pin. Diagram of 555 timer IC. The 555 timer IC contains 8 pins. The 555 is a highly stable device for generating accurate time delays or oscillation. Additional terminals are provided for triggering or resetting if desired. For a stable operation as an oscillator, the free running frequency and duty cycle are accurately controlled with 2 external resistors and 1 capacitor, which we are going to do in our second experiment with IC74LS163. Now I am going to describe all pins one by one. The first pin is a ground. The second pin is a trigger responsible for transition of the flip-flop from set to reset. The third pin is an output. The fourth is a reset, which gives negative pulse applied to this pin to disable or reset the timer. The fifth pin is a control voltage, which controls the threshold and trigger levels. It determines the pulse width of the output waveform. The sixth pin is a threshold pin, which compares the voltage applied to the terminal with a reference voltage of 2/3 VCC. The seventh pin is a discharge, which opens collector output, which discharges a capacitor between intervals. And the 8th pin is a VCC, which is connected to a input voltage 5 volt, which we provide through ADLM1000. Here is my circuit. In this video, I am going to do 2 experiments. The purpose of both experiments are same. In first experiment, I am going to use IC74LS163 with IC-CD401006, and in second experiment, I am going to use 74LS163 IC with 555 timer IC. I will demonstrate second experiment later. Let's focus on first one. In this experiment, I am also going to use ADLM1000. ADLM1000 is providing 5 volt to our circuit and also clock pulse with a clock pulse of 100 Hz to our Cd401006. I am going to use 4 pin of ADLM1000. Gray is connected to channel A, black is connected to ground, white is connected to a 5 volt input voltage, and green is connected to a channel B. The 7th pin of Cd401006 is connected to a ground. The 14th pin is connected to an input voltage of 5 volt, and the first pin is connected to a channel A. ADLM1000 is providing clock pulse of 100 Hz to a first pin of Cd401006. The IC will modify that clock pulse and give back from second pin, and that modified clock pulse directly go into second pin of 74LS163, which is a clock pin. The first pin of 74LS163, which is a clear pin, is connected to an input voltage or set high. The 8th pin is connected to a ground. The 7th pin, which is ENP, and also the 10th pin, which is ENT, are set to high. The 9th pin, which is a load, is connected to input voltage. and third, fourth, fifth and sixth pin is the input, and 14, 13, 12, 11 is our output, in which 14 is a least significant bit LSB and 11 is a MSB, most significant bit. And all this output is connected to a LED which shows countdown of our bit. 4 bit starts from 0000 and ends at 1111. And all this LED is connected to a 100 kilo ohm of resistor. It helps LED to not blow up. And this all jumper wire is connected to a vertical pin of our breadboard to sort that vertical pin. Here is my second experiment. In this experiment, I am going to use IC 74LS163 with IC 555, which is a timer IC. And I am also using ADLM 1000, and I am using 3 pins of ADLM. The black wire is connected to a ground, the white is connected to a 5 volt, and the green is connected to a channel B. We will measure output of IC 74LS163 with a channel B pin. This is my 555 timer IC. The first pin is connected to a ground. The second, which is a trigger pin, is connected to a threshold pin, which is at 6 pin. Trigger pin is responsible for transition of the flip-flop from set to reset, and the threshold compares the voltage applies to the terminal with a reference voltage of 2/3 VCC. The fourth pin, which is a reset, is connected to a 8 pin, which is a VCC, and VCC, which is connected to input voltage of 5 volt. The third pin of 555 timer IC, which is an output, it is connected to a second pin of 74LS163, which is a clock pin. 555 timer IC is giving output to a clock pin of 74LS163, and 74LS163 starts counting of 4 bit from 0000 to 1111. This LED shows us the countdown of 4 bits, and 8 pin is of 74LS163 is connected to a ground, and the 7th pin, which is a ENP, is connected to input voltage, or we can say it is set to a high. The 9th pin, which is a load pin of 74LS163, is connected to input voltage and also is connected to ENT. This black and red wire shows ground and input voltage. Here in 555 timer IC, I am using two resistor of 1 kilo ohm and one capacitor of 4.7 microfarad, because for a stable operation as an oscillator, the free running frequency and duty cycle are accurately controlled with 2 external resistors and 1 capacitor. This resistor between first and 16 pin of 74LS163 is not making any difference. We can connect wire also.